Hello everyone, my name is Nathan Zimmerman and I am incredibly excited to demonstrate to you my latest 5th generation oven controller. Now what this system is meant to be is it's meant to be a system that is affordable, reliable, available, and very feature rich, such that it empowers all the users in their various applications. I've had people approach me who have wanted to use this in cooking, in arts and crafts, or I've been approached by electronic hobbyists, of course, such as myself, to use it in a reflow oven application. Now the system is very easy to use. It has a touchscreen interface, as well as a thermocouple input, a solid-state relay input, and then finally it has a USB interface which allows for some very powerful features. Now when I say system, I mean that this controller comes as a kit, and this kit includes all the core fundamental components that you need to convert your everyday toaster oven into a reflow oven controller, for example. It comes with a controller, which of course has the LCD display on the back. It comes with wiring to connect your controller to your relay. It comes with a thermocouple, which is high temperature rated and low thermal mass. And finally, it comes with a solid state relay, which of course allows you to turn your heating elements on and off with your controller. Now the kit itself comes in 3 different variations. You have a 3.2 inch version, a 2.4 inch version, and finally I have a standalone version that is solely controlled by the USB interface. Now keep in mind, all 3 versions take advantage of the USB interface either for power or for downloading and setting your own custom profiles. Alright, so a quick backtrack. In my application, I of course use these controllers as a reflow oven controller. So what does that mean? Reflow oven controllers help with assisting from going from primarily through-hole based designs such as this to primarily surface mount designs such as my new controller like this. And how it works is you start out with a blank PCB, you apply solder paste to that PCB through using a syringe such as this, which contains solder paste, or if you're really lucky and are willing to pay for it, you can get a stencil such as this, which makes applying the paste a whole lot easier. Once you have the paste on your PCB, you simply need to place the components on top of the PCB as well as the paste. So to do that, you can of course use tweezers and apply the components like that, place them like that, or you can use a vacuum pump, or if you're really lucky, you could use a pick and place machine. Now once you've done all that, all the prep work for using the reflow oven is finished. And in a sec here, I'll show you reflowing one of my reflow oven controllers. So of course you take your PCB with the solder paste on it as well as the components and you put it in the reflow oven. Alright, one of the nice things about this controller is it is incredibly easy to reflow your PCB. As you can see on the screen, there's 3 profile slots. What you put in these profiles is up to you. To reflow my oven controller, I'm going to simply go to the lead-free profile, and then I'm going to hit start, and away we go. It is that simple. Now you'll see that there is a red line which shows the target of the profile, and once we've gotten past the preheating phase here, in a moment you'll start seeing a green line appear on the plot, which of course is our live feedback, such that we can see how well our controller is doing versus the plot or the profile that we give it. All right, so perhaps one of the most powerful tools of the Zolus Reflow Oven Controller is a software tool which allows you to simply draw in your own profile and download it to the controller. Here's a quick example of creating a lead-free profile. So now that we've drawn our profile, how do we know if this profile is compliant with industry standards or is safe for our components? To check this, I created a compliance tab which will compare the profile that we drew versus industry standards, and it'll also allow us to compare industry standards versus the actual profile that we run on the controller. So the next step is to download this profile to the controller and run it and see if it is still industry compliant. As you can see, the profile is now finished, and we are indeed industry compliant. Now you notice there is a little bit of disparity between the target and the received data. Part of this is the fact that I'm using a convection oven as opposed to a radiation-based oven, and I'm fighting physics. However, I do give the users the ability to adjust the gains of the control system should they wish to tweak their profile if the given accuracy is not sufficient. However, for me and my application, this is indeed industry compliant, which is definitely adequate. All right, so now you've seen a controller reflow a PCB, you've seen the touchscreen interface of the controllers, and you've also seen the PC tool, which allows you to fully customize these controllers should you so wish for your various applications. So what I have here I believe to be an incredibly complete and potentially good product. However, I'm still doing this Kickstarter because I need your support. In the past, I haven't been able to keep up with the manufacturing demands of these controllers on my own. Consequently, with your support, I can overcome the high entry-level cost to manufacturing in bulk, again, such that these controllers can be affordable and available for everyone. That is my goal. So, in addition to your support, I can also really use your feedback because I want to make these controllers the best controllers that they could possibly be. So any questions, concerns, any general feedback, I would love to hear it, and I'm greatly looking forward to hearing from you.